Hello and welcome to Mysteries of Earth. Today we face one of the most mind-bending questions in all of cosmology. If nothing lies beyond the universe, what is it expanding into? For generations we imagined the cosmos as a vast bubble growing through an empty void. But what if there is no outside at all? What if space itself is stretching, creating new reality as it expands? From the echoes of the Big Bang to the limits of the observable universe, we'll uncover how the cosmos grows without ever moving through anything, and what that means for the nature of existence itself. If you love exploring science, mystery, and the unknown, make sure to subscribe to Mysteries of Earth and join us as we journey to the edge of everything we can see and beyond. If the universe is expanding, what is it expanding into? It's a question that seems simple, almost innocent, yet it carries the weight of everything we know about existence. To ask what lies beyond the universe is to test the limits of imagination itself, because the answer is unlike anything our minds are built to grasp. We imagine expansion as motion, something pushing outward, moving into something else, like ink spreading through water or an explosion in the sky. But in truth, the universe is not expanding into anything. Space itself is expanding. The stage is not fixed. The stage is growing. And that's where the mystery begins. For most of human history, the cosmos seemed eternal, static, unmoving, infinite in all directions. Then a century ago we discovered something extraordinary. Distant galaxies were drifting away from us, their light stretched toward the red end of the spectrum. The farther they were, the faster they fled. This was Edwin Hubble's discovery, the first whisper of a truth that would change everything. The universe was not fixed, it was growing. At first, scientists tried to picture this growth as motion through a pre-existing void, as though galaxies were traveling outward through empty space. But that image doesn't quite fit, because what's actually growing is space itself. Imagine dots drawn on the surface of a balloon. As the balloon inflates, each dot moves farther from the others, not because they're traveling across the surface, but because the surface itself is stretching. Now imagine that balloon's surface as all of space, and every dot as a galaxy. The key insight: there is no center of expansion, no spot where it all began spreading outward. Every galaxy sees every other galaxy moving away, because the entire fabric is expanding everywhere all at once. But here's where the analogy breaks. Because the balloon surface is two-dimensional and the universe is three-dimensional, there's no inside or outside to inflate into. The universe expands within itself. There's nothing beyond it, no border, no cosmic wall. So where does this expansion end? Where is the edge of everything? In truth, it doesn't have one, at least not in the way we imagine. What we call the edge of the universe is not a place in space, it's a limit in time. From our small blue world, light has been traveling toward us for 13.8 billion years, the age of the cosmos itself. That's how far we can see. But while that light journeyed here, the universe continued to stretch. Those distant galaxies whose light began when everything was still young are now roughly 46 billion light-years away. That immense distance defines what we call the observable universe. Beyond that horizon, there's more: space, matter, energy, but we'll never see it. Its light hasn't had time to reach us yet. So the edge of our universe isn't a wall in space, but a boundary of sight, an edge of light. Look far enough into the dark, and we see not galaxies, but the faint, ancient glow of the cosmic microwave background, the oldest light in existence. It's the remnant of a time 380,000 years after the Big Bang, when the universe finally cooled enough for atoms to form and light to travel freely. Beyond that, the universe was opaque, a dense, blinding plasma where photons could not move. What came before that moment is hidden forever behind that glowing veil. In other words, our cosmic horizon is not the end of space, but the end of visibility. Everything beyond that glow, whether infinite or finite, is unknowable to us. Not because it isn't there, but because its light will never reach us. This realization changes everything. It means the universe we see, the hundreds of billions of galaxies, the endless web of cosmic structure, may be only a small part of a far grander reality. Some cosmologists propose that our observable universe is just one bubble in an infinite cosmic sea, each bubble born from quantum fluctuations in an eternal inflationary field. These bubble universes could exist side by side, each expanding into its own region of space-time, each with its own laws of physics, its own constants, its own potential for life. Ours might be just one in an endless multiverse, a single spark in an infinite storm of creation. Others suggest that space might curve back on itself, like the surface of a sphere, so that traveling far enough in one direction could eventually bring you back to where you started, though the scale is so vast, no traveler could ever make the journey. And yet, even if the universe is infinite, we are forever confined within our horizon, a cosmic island adrift in an invisible ocean. So, what lies beyond the edge? The most honest answer is, we don't know, and perhaps we never will. Because beyond the limits of what light can show us lies a realm forever out of reach, not by distance but by time. To look farther is to look deeper into the past, and at some point we hit a wall where time itself begins. In that sense, the edge of the universe is really the edge of us, the limit of human observation, of what our instruments, our theories, and even our imagination can touch. And yet, this limitation is what makes the universe so hauntingly beautiful. It hides more than it reveals. Every discovery, every breakthrough only deepens the mystery. The cosmos expands, and so does our sense of wonder, a parallel growth of space and understanding. Maybe that's the true nature of the edge. It isn't a line to be crossed, but a frontier to be forever pursued, a horizon that recedes as we move toward it. So when we look up at the night sky, when we trace the faint light of galaxies billions of years away, we're not just looking outward, we're looking back into time, into creation, into the very heart of everything that is. And somewhere beyond the reach of light, beyond what we can ever know, the universe continues to unfold, silent, endless, and eternal. At first glance, it seems simple. The universe is expanding, galaxies are drifting apart. But look deeper and the simplicity dissolves into something far stranger, because those galaxies aren't really moving through space. Instead, space itself is stretching. The very fabric of reality is growing larger. It's a concept that defies instinct. We're used to motion, to things traveling through something else. A car moves through air. A planet orbits through space. But in the cosmic sense, there is no through. The galaxies aren't racing across a pre-existing emptiness. They're riding along with the expansion of the universe itself. To picture this, cosmologists often turn to a simple, yet surprisingly profound analogy. the surface of a balloon. Imagine the cosmos not as the air inside the balloon, but as the surface itself, a two-dimensional world curved in a higher dimension. Now mark a few tiny dots on it. As the balloon inflates, each dot moves away from all the others. None of the dots are traveling across the surface. The surface itself is expanding. Every point sees every other point receding. No dot is at the center. No dot is special. That is our universe, only in 3 dimensions instead of 2. And just like the balloon's surface, the universe has no edge and no outside. The expansion isn't pushing into something beyond it. It's happening everywhere, equally, all at once. This idea that space itself expands is not just metaphor. It's written in the equations of Einstein's general theory of relativity. In Einstein's view, space and time are woven together into a single entity, space-time, a dynamic fabric that bends, stretches, and curves in response to mass and energy. A massive object like a star or a planet tells space-time how to curve. That curvature, in turn, tells matter how to move. Gravity is not a force pulling things together, but the geometry of space-time itself guiding the motion of everything within it. But here's the astonishing part. Space-time isn't rigid. It's flexible, elastic. It can warp, ripple, and, as we now know, it can expand. Einstein's equations predicted it long before we saw it, but even he found the idea so unsettling that he tried to eliminate it, adding what he called a cosmological constant to keep the universe static. It was only later, when Hubble discovered that galaxies are moving apart, that Einstein realized he'd been looking at the universe's true nature all along. So what does it really mean when we say space expands? It means that the distances between unbound galaxies increase with time, not because the galaxies are flying apart, but because the metric that defines distance itself is changing. Think of 2 raisins baked into a loaf of bread. As the dough rises, the raisins move farther apart, not because they're traveling through the dough, but because the dough itself is stretching. The bread is space. The raisins are galaxies. And just as no raisin sits at the center of the loaf, no galaxy sits at the center of the universe. Every point expands away from every other point. If you could somehow step outside the universe, which of course you can't, you wouldn't see an explosion radiating outward. You'd see something far stranger, a self-contained, boundaryless fabric inflating from within itself. This expansion carries profound consequences. It means that light traveling through the cosmos doesn't just move across empty space. It moves through stretching space. As space expands, the light's wavelength stretches with it, shifting toward the red. This is the cosmological redshift, the signature of expansion itself. Every distant galaxy we observe appears redder than it should be, not because of motion alone, but because the space between us and the galaxy has grown while the light was en route. This is why we say the universe isn't just getting older, it's getting bigger. And the farther we look, the more ancient the light we see, the more stretched the cosmos appears. In this expanding fabric, time and space are inseparable. Expansion is not something happening within the universe. It is the evolution of the universe's geometry itself. But if space is stretching, what exactly is stretching into what? That question has no answer because it contains a false assumption that there's something outside to stretch into. There isn't. The universe has no outer edge. It doesn't need a surrounding void to expand into, any more than the surface of Earth needs an outside to be curved. Space expands within itself. The only thing increasing is distance, not volume within a container, but the fabric of the container itself changing shape. This is perhaps the hardest truth to accept. Our intuition fails in a cosmos with no center, no edge, and no beyond. Everywhere is the center of expansion. Every observer in every galaxy would see all other galaxies moving away from them, as though they alone occupied the heart of creation. Yet no one does. Every point is equally valid. Every direction is the same. This is what scientists call cosmic isotropy, the idea that, on the largest scales, the universe looks roughly the same no matter where you are or which way you look. And yet within this serene uniformity lies a subtle imbalance, a mysterious force causing the expansion not just to continue, but to accelerate. In the late 1990s, astronomers studying distant supernovae discovered that galaxies are receding faster and faster over time. The expansion isn't slowing down under gravity's pull. It's speeding up. Something invisible, something deeply woven into space-time is pushing the cosmos apart. We call it dark energy, Sol. Though the name is more mystery, that an explanation. It's not an energy we can detect, not a substance we can point to. It's simply the term we give to the unknown mechanism driving the expansion. Today we believe dark energy makes up about 68% of the total energy of the universe. It's the quiet architect behind cosmic acceleration, an unseen hand stretching the fabric of reality itself. So the universe grows, not into space, but as space. The galaxies drift apart, not because they're racing outward, but because the grid beneath them stretches. The very scale of reality changes, and everything within it changes with it. It's a strange thought, that the distance between stars, between galaxies, between clusters of galaxies, is an ever-growing measure of the universe's own heartbeat. The cosmos expands silently, endlessly, and we, on our small world orbiting an ordinary star, are part of that vast unfolding. And yet, as space stretches, it also carries away the light that reaches us. The farther galaxies move, the fainter their glow becomes. One day, in the far future, their light will fade completely beyond visibility. The universe will appear empty, dark, and still. Not because it has stopped expanding, but because it has expanded too much for us to see. The fabric of space will continue to stretch, carrying the galaxies beyond the horizon until only silence remains. But that is a mystery for another chapter. A glimpse into the future of expansion itself. There is a distance beyond which we can never see. Not because our telescopes aren't strong enough, or because the light is too faint, but because the universe itself will not allow it. Roughly 46 billion light-years away, in every direction, lies the edge of what we can observe. A boundary, not of space, but of time and light. The cosmic horizon. Beyond it, the universe continues. But we can never look past that veil, because beyond that line, light has not had enough time to reach us since the birth of the cosmos itself. This is not just a limit of technology, it is a limit written into the structure of reality. When we gaze at the night sky, we are not seeing the present, we are looking back through time. The light from the moon takes just over a second to arrive. From the sun, 8 minutes. From the nearest star, 4 years. And the farther we look, the older the light becomes. The galaxies in Hubble's deep field shine from billions of years ago, when stars were young and the universe was only a fraction of its current age. Every distant photon is a time capsule carrying with it a record of when and where it began its journey. But there is a limit to how far back those records can go, because there was a time before which light could not travel freely, a time when the universe was shrouded in a dense, glowing fog. Go back 13.8 billion years, and you reach the cosmic dawn, the moment when everything began to become visible. In the beginning, the universe was a searing plasma of energy and particles, too hot, too chaotic for atoms to form. Photons, the particles of light, were trapped in an endless fog of collisions, scattering off free electrons in every direction. Only when the universe cooled enough for atoms to form, about 380,000 years after the Big Bang, could light finally escape. That first light still surrounds us today, stretched and are led by billions of years of expansion. We call it the cosmic microwave background, the afterglow of creation itself. When we look out into deep space, we are seeing this ancient light. It is the farthest wall our eyes and our instruments can ever touch. Beyond it lies the universe as it was before light could travel, a hidden realm sealed behind the fog of its own birth. This is what scientists mean by the cosmic horizon. It is not a physical edge, not a wall in the distance. It is a boundary of knowledge, the farthest point from which any signal, any photon could have reached us since time began. It is a limit drawn not by space, but by the speed of light and by the age of the cosmos itself. The universe is about 13.8 billion years old. But because space has been expanding all that time, the most distant regions we can observe are now 46 billion light-years away. That distance defines the observable universe, the sphere of everything we can possibly see. Outside that sphere, space continues. Galaxies exist, stars are born, light travels, but none of it can ever reach us. Those realms are forever cut off from our perception, not because they don't exist, but because the flow of time and the expansion of space have made them unreachable. This idea, and that there are parts of the universe we will never see, changes how we think about reality itself, because it means that what we call the universe is not the whole of existence, it is merely the observable part, the bubble of space and time connected to us by light. Beyond it, other regions may look very different. They may have formed stars sooner or later. They may contain different galaxies or even follow slightly different physical laws. But we will never know. No light, no information can cross that horizon to reach us. It is the ultimate cosmic censorship, a boundary between the knowable and the unknowable, and yet the horizon is not fixed. It moves, it changes. As time passes, light from more distant regions continues to arrive. Our observable universe slowly expands, revealing parts of the cosmos that were once beyond our reach. But this expansion is a race we cannot win. Because while our horizon grows, the universe itself stretches faster and faster, driven by the mysterious pressure of dark energy. In the distant future, the acceleration will pull galaxies so far away that their light will never reach us. Even light that is already on its way may one day be swept beyond our cosmic horizon, lost forever to the accelerating fabric of space. The universe, in time, will become a lonely place, a dark island of stars surrounded by silence. The cosmic horizon, then, is more than a scientific limit. It is a mirror for the boundaries of human understanding. For every question we answer, what lies at the center of a black hole? What existed before the Big Bang? What happens beyond the observable universe? We encounter another horizon of ignorance. Each discovery expands our vision, but also deepens the mystery. Because even as we uncover more of the cosmos, we realize that most of it will forever remain unseen. The observable universe, this 93 billion light-year wide sphere, may feel infinite to us. But in truth, it's a small patch in an ocean without end. A finite window into a reality that stretches far beyond imagination. Every galaxy we see is part of that window. Every photon that reaches our eyes is part of its story. And everything beyond it, and the countless galaxies, the unknown structures, perhaps even other universes, will remain forever hidden beyond the veil of light and time. This is the limit of knowledge. Not because we lack the tools, but because the universe itself has drawn the line. The cosmic horizon is, in a way, a boundary between bay and mystery, between what can exist for us and what exists in itself. It reminds us that our understanding of reality is shaped not just by what is out there, but by what can reach us here. Every time we look at the night sky, we are looking into the past toward a horizon that defines everything we can ever know. And beyond that horizon lies everything we cannot, the hidden majority of the cosmos, forever just out of reach. What lies beyond the horizon? It's a question that turns our gaze from what we can see to what we can only imagine. Beyond the 46 billion light-year boundary of the observable universe stretches a realm forever hidden from us, a region where light has not yet had the time to arrive, where the laws of physics may bend into unfamiliar forms, and where reality itself may take on shapes we cannot comprehend. For most of human history, we believed the universe was finite, a celestial sphere containing everything that exists. But the deeper we looked, the more we realized that the cosmos refuses to be contained. Our instruments now whisper a quiet, unsettling truth. What we see may be just one fragment of something vastly larger. The observable universe, everything we can ever detect, is not the whole of existence. It's merely the visible portion of a cosmic ocean that might stretch on without end. If the universe is indeed infinite, then it has no edge, no outside, and no limit. And within an infinite expanse, something extraordinary happens. The possible becomes inevitable. Because if space truly extends forever, every configuration of matter, every possible arrangement of atoms must occur not just once, but infinitely many times. Somewhere out there, far beyond the reach of light, there may be another Earth, another sky, another you, standing under another night, asking the same impossible question: what lies beyond? These are not fantasies, but consequences of mathematics. Infinity does not permit uniqueness. It demands repetition. Just as a deck of cards shuffled endlessly will eventually return the same sequence, the cosmic deck, if infinite, contains every possible variation of galaxies, stars, and lives, Somewhere beyond our horizon, there may exist civilizations that mirror our own, others that evolve differently, perhaps guided by laws of physics we cannot yet imagine. Some cosmologists propose that beyond our observable bubble lie regions of space where matter clumped differently in the first moments after the Big Bang, where gravity sculpted alternate cosmic histories. In some of these universes, stars may never have formed. In others, galaxies may crowd together in impossible densities. There could be realms where the speed of light, the pull of gravity, or even the structure of time itself diverges from the physics we know. To us, those places are unreachable, not because they do not exist, but because the universe expands faster than light can cross it. The space between us and them grows ever wider, carried by the relentless stretching of the cosmic fabric. What lies beyond our horizon is lost not to destruction, but to distance. Those realms are not elsewhere in space. They are elsewhere in time, forever receding into the unobservable. And yet, even in their absence, they influence us. Quantum theory suggests that every fluctuation, every event that could happen, might in some sense does happen, branching into separate realities, all unfolding simultaneously. It's a vision of a multiverse born not from speculation, but from the mathematics that underpin the very structure of the cosmos. In this picture, our universe is but one bubble among countless others, each emerging from the quantum foam of creation, a vast sea of inflationary space, spawning new domains endlessly. Some of these bubbles may collide, merging their realities for a moment before drifting apart again. Others may exist forever isolated, their light never touching ours. But even if we never see them, the possibility itself reshapes our understanding of existence. It reminds us that what we call the universe may be only a local phenomenon, a small region of a grander reality beyond any conceivable reach. Still, within that immensity, there is something deeply human. We are finite beings standing inside an infinite story. The horizon does not limit the universe. It limits us. Our senses, our instruments, our very comprehension are bounded by light. And yet, the mind dares to stretch further. We imagine, we calculate, we dream of what lies beyond. Perhaps that is our role, to be aware of the edge and to wonder. Because in wondering, we extend that edge just a little farther. Each discovery, each equation, each telescope turned toward the dark expands, not the universe itself, but our understanding of it. When we think of infinite space, it's easy to feel small, a single spark in a sea without shore. But infinity also means connection. Every atom in your body, every photon that strikes your eyes, every breath you take is part of that same boundless continuum. The universe may be vast beyond comprehension, but it is not foreign to us. We are made of it, sculpted from the same patterns that ripple through the endless void. Beyond the horizon, there may be endless variations of the same truth, infinite reflections of reality repeating across eternity. But here, in this one universe we can touch, the mystery is enough. The unreachable isn't meant to be conquered. It's meant to be contemplated. Because the moment we grasp that the universe might be infinite, we realize something profound. We too are part of that infinity, not separate from it, but expressions of it, conscious fragments of an endless whole. So, what lies beyond the horizon? Perhaps everything. Perhaps nothing we can ever imagine. But what we do know is this: the boundary of knowledge is not fixed. like the expanding universe itself, our understanding grows. And as we stand here at the edge of the visible cosmos, staring into a darkness that may never end, we find meaning not in what we can see, but in what forever lies beyond our reach. What will be the final chapter of the universe? Every beginning carries within it the seed of an ending, and the cosmos is no exception. From the first flash of creation to the countless galaxies now spiraling through the dark, the universe has been on a journey with a destination we still can't see. Its fate depends on a force we barely understand, a silent power known as dark energy. It is invisible. It cannot be touched, measured directly, or captured in any detector. Yet it shapes the destiny of everything, from the smallest atom to the largest cluster of galaxies. Dark energy drives the expansion of space itself, accelerating it faster and faster, and its behavior will determine how the story ends. There are three great visions of that end, each a mirror of the same cosmic truth, each more haunting than the last. The heat death, the long fade into darkness. If dark energy continues as it is now, steady and unrelenting, the universe will expand forever. Galaxies will drift apart until their light can no longer reach one another. The night sky will grow darker, colder, lonelier. Stars will exhaust their fuel and die one by one. First the giants, then the suns like ours, leaving only white dwarfs glowing faintly in the endless dark. Even they will fade, cooling into black dwarfs, cold remnants of once burning stars. As time stretches into unimaginable scales, trillions upon trillions of years, gravity will loosen its hold. Galaxies will dissolve. Black holes will dominate, devouring the last of the matter, until even they evaporate into nothingness through Hawking radiation. What remains is not chaos, but silence. A thin mist of subatomic particles spread across an endless, frozen void. The universe doesn't collapse or explode. It simply fades. This is the heat death, the final equilibrium, where energy is evenly distributed and nothing more can happen. No stars, no life, no change. Only eternal stillness. It is not a fiery end, but a quiet one. The death of possibility itself. The Big Rip. When space itself tears apart. But dark energy might not remain constant. It might grow stronger. If its power increases over time, its expansion could accelerate beyond control, tearing galaxies, stars, planets, even atoms apart. At first, galaxies would drift beyond sight, vanishing faster than light can chase them. Then, as expansion accelerates further, gravity's grip would fail, solar systems would unravel, planets would be flung into the void. Eventually, even molecules would be torn apart as space itself stretches faster than the forces that bind matter together. In the final instant, perhaps just fractions of a second before the end, the very fabric of space-time would rip itself to pieces. The laws of physics would cease to exist in any recognizable form. This is the Big Rip. A universe destroyed not by collapse, but by its own relentless growth. Expansion becomes disintegration. Creation devours itself. It is the ultimate paradox. Infinity becoming nothing. The big crunch. The universe turns inward. Yet there is another possibility. That dark energy could weaken or even reverse. If gravity one day overcomes expansion, the universe could begin to contract. Galaxies would start to move closer, the night sky growing brighter as everything falls back toward everything else. Eventually, galaxies would collide, stars would merge, and the temperature of space would rise once again. The cosmic web would tighten into a single, incandescent point, the mirror of the Big Bang. This is the Big Crunch, a universe collapsing into itself, returning all energy and matter to a single origin. And perhaps, just perhaps, that singularity could ignite again, birthing a new universe in its wake, continuing a cycle of infinite rebirths. Expansion, collapse, creation, and renewal, the cosmos breathing in and out across eternity. It is a vision both terrifying and poetic, an endless rhythm of beginnings and endings. Each of these fates tells a different story, but they all share one truth. Nothing lasts forever. Even eternity has directions, forward or backward, expanding or collapsing. For now, the evidence favors the heat death, a universe that will expand forever, cooling slowly into silence. But we are only beginning to understand the nature of dark energy. It could change, evolve, or reveal laws we have never imagined. The fate of the universe isn't just a question of physics. It's a reflection of existence itself. What does it mean to live in a cosmos that will one day fade? What meaning does creation hold if all light eventually goes out? Perhaps the answer lies not in the ending, but in the knowing. To witness the rise and fall of stars, to grasp, even for a moment, the immensity of time, that is its own kind of eternity. Because in this cosmic story, we are both fleeting and infinite, made of particles that will one day drift apart, yet conscious of the journey itself. The universe will end, but the wonder it inspires, Bahamal, that longing to understand, may be its most lasting legacy. So, as we look ahead to the final destiny of everything, we stand in awe not of what will be lost, but of what it means that we were ever here to see it at all. The story of the universe may end in silence, but for now, it still speaks. And its voice is the same one that echoes within us. The drive to ask, to seek, to know. For in understanding the end, we begin to understand ourselves. For most of cosmic history, gravity ruled everything. It pulled gas into stars, stars into galaxies, and galaxies into clusters that stretched across the heavens. It was the sculptor of structure, the invisible hand that shaped the universe from chaos. But then, billions of years after the Big Bang, something changed. The universe began to speed up. Not slow down, as gravity would demand, but expand faster, as if pushed by an unseen force. This discovery stunned astronomers. It defied everything we thought we knew about the cosmos, and from that mystery, a name emerged: dark energy, the Great Reversal. For decades, scientists assumed that the universe's expansion, first discovered by Edwin Hubble in the 1920s, must be decelerating. Galaxies, after all, were moving apart, but gravity was always pulling them back. Eventually, it was thought expansion would stall, or even reverse into a cosmic collapse. But in 1998, two teams studying distant supernovae, exploding stars billions of light-years away, made a shocking discovery. These cosmic explosions were dimmer than expected, farther than they should have been. That meant the universe wasn't slowing down, it was accelerating. Something stronger than gravity was pushing everything apart. stretching space itself faster with time. It was as if the universe had changed gears, switching from deceleration to acceleration about 5 billion years ago. The cosmic slowdown had ended, and a new reign had begun. The nature of the invisible. What exactly is this force? We don't know. We call it dark energy, not because it's dark like shadow, but because it's hidden from all detection. It doesn't emit light, absorb it, or scatter it. We can't see it, only its effect on the expansion of space. Yet dark energy makes up nearly 70% of the entire universe. The stars, galaxies, and matter we can see account for less than 5%. The rest, a vast majority of existence, remains a mystery. To imagine this is to confront how little we know about reality itself. Everything we touch, everything we are, floats in a sea of something unseen, a force that silently drives the universe apart. The cosmological constant, Einstein's ghost, the idea of such a force isn't entirely new. Over a century ago, Albert Einstein proposed something called the cosmological constant, a mathematical term he inserted into his equations of general relativity. Einstein imagined it as a kind of built-in energy in space, preventing the universe from collapsing under its own gravity. But when Hubble discovered that the universe was expanding, Einstein abandoned the constant, calling it his greatest blunder. And yet decades later the idea returned, stronger than ever. The accelerating expansion we see today behaves much like Einstein's cosmological constant, a uniform energy that fills all of space, unchanging and in time, pushing everything apart. Could Einstein's blunder have been his most profound insight? The vacuum that isn't empty. To grasp dark energy, we must rethink what nothing means. Even in the emptiest regions of space, where there are no atoms, no radiation, no light, quantum physics tells us the vacuum is not truly empty. It teems with fleeting particles that appear and vanish, a constant hum of energy woven into the fabric of space-time itself. Some scientists believe that dark energy may arise from this vacuum energy, the energy of nothingness, a property not of matter, but of space itself. Every cubic meter of space carries this energy, and as the universe expands, there's simply more space for that energy to exist, fueling further expansion. In this way, dark energy isn't something inside the universe, it is the universe, the energy of the void, the silent pulse of creation continuing long after the fireworks of the Big Bang faded. The cosmic balance shifts. In the early universe, dark energy was almost irrelevant. Matter and radiation dominated then, their gravity strong enough to slow expansion. But as the universe stretched, matter thinned out, spreading across a growing volume of space. Meanwhile, dark energy, constant, unchanging, began to dominate. Around 5 billion years ago, it overtook gravity, and since then it has been the master of the cosmos. Now, every galaxy is receding faster and faster. The universe grows emptier, colder, and more isolated. In the far future, distant galaxies will vanish from view altogether, pulled beyond our cosmic horizon. The night sky will dim until only the faint light of our local group remains. Dark energy will rule absolutely, a quiet emperor presiding over a darkening empire. The theories of the unknown. But what is it really? Some physicists suspect dark energy is truly constant, an intrinsic property of space, forever steady. Others believe it might evolve with time, growing stronger or weaker, changing the universe's fate. Some even imagine it as a new kind of dynamic field, something that flows, ripples, or interacts subtly with matter. A quintessence, the fifth element, beyond earth, air, fire, and water, modern echo of an ancient idea. And a few more radical ideas suggest that our understanding of gravity itself might be incomplete. Perhaps dark energy isn't a thing at all, but a symptom of physics we haven't yet uncovered. Maybe the fabric of space-time bends and behaves in ways we cannot yet imagine. Whatever the truth, it hides behind a veil of cosmic scale, beyond our laboratories, beyond our reach, visible only through the grandest experiment ever conducted, the universe itself. The universe's silent reign, today, dark energy, defines the universe's evolution more than anything else. It shapes the future of all things. Whether galaxies will drift apart forever, whether atoms will endure, or whether space will one day tear itself apart. We live in its age, an era where the visible universe is but a spark within a vast, invisible sea. The reign of dark energy is not loud nor violent. It is slow, patient, inevitable. Like a tide that never stops rising, it moves silently, reshaping reality itself. And yet within this expanding void, tiny creatures, bound by atoms, driven by curiosity, have noticed. We have measured its effects, given it a name, and asked what it means. In that act, something remarkable happens. The universe, through us, becomes aware of its own acceleration. The cosmos expands, and we expand with it, not in distance, but in understanding. Perhaps one day, we'll uncover the true nature of this mysterious force. Perhaps dark energy is not an ending, but a doorway, a sign that our universe is part of something larger, something beyond our horizon of understanding. Because every mystery in science, every unanswered question has always led us deeper into truth. And as dark energy stretches the cosmos outward, it also stretches the boundaries of human thought, expanding not just space, but the very idea of what reality can be. For in the reign of dark energy, we are reminded that the greatest forces may be invisible, and the greatest discoveries still lie ahead. For all its brilliance, the universe we see is not the universe that is. The stars, the galaxies, the glowing clouds of gas, they are but the decorations on a deeper, invisible framework. An unseen architecture that holds everything together. Without it, galaxies would never have formed, stars would never have gathered, and the universe would be little more than a thin mist, expanding forever into nothing. This hidden foundation is called dark matter, the silent architect of the cosmos, the hidden majority. When astronomers first measured the movements of galaxies, they noticed something profoundly strange. The stars at the outer edges of galaxies weren't slowing down as they should. They were moving too fast, orbiting as though held in place by some unseen hand. According to Newton's laws, the visible matter, the stars, gas, and dust, simply wasn't enough to explain such motion. Something else had to be there, something massive, invisible, and everywhere. Today, we call that something dark matter. It makes up about 85% of all matter in the universe. Yet it neither emits nor absorbs light. We cannot see it, cannot touch it, and cannot directly detect it. But its gravity reveals its presence, shaping galaxies, bending light, and weaving the large-scale structure of the cosmos. The universe we know, the one written in starlight, is just the surface. Beneath it lies a shadow universe, silent but fundamental. The cosmic web. Imagine zooming out, far beyond galaxies, beyond clusters, until the universe becomes a vast 3D tapestry. At that grand scale, matter isn't spread evenly. It forms an intricate cosmic web, long filaments of galaxies stretching across hundreds of millions of light years, intersecting at glowing nodes where clusters form. These filaments are not made of ordinary matter alone. They are built primarily from dark matter, forming a vast, invisible skeleton upon which visible galaxies are strung like beads of light. In computer simulations, dark matter behaves like a cosmic glue. Tiny fluctuations in the early universe, small differences in density, grew under gravity's pull, creating dark matter halos that later drew in gas and dust. Within those halos, stars ignited, galaxies spun to life, and worlds like ours took shape. Dark matter didn't just shape the universe, it enabled it. It is the scaffolding on which cosmic history was built. The clues in the light. If dark matter is invisible, how do we know it's real? We see its fingerprints everywhere. When light from distant galaxies passes through massive clusters, it bends and warps, an effect called gravitational lensing. The amount of bending reveals the true mass of those clusters, and it's far greater than what their visible matter can explain. The cosmic microwave background, the afterglow of the Big Bang, also holds clues. Subtle patterns in its temperature map show how matter clumped in the early universe. These patterns only make sense if dark matter was there, shaping the evolution of structure from the very beginning. And on the largest scales, galaxy surveys reveal a universe that behaves exactly as if it were threaded with invisible mass, binding everything with an unseen hand. The evidence is overwhelming. We just don't know what it is. The search for the invisible. Physicists have spent decades trying to uncover the true nature of dark matter. One possibility is that it's made of WIMPs, weakly interacting massive particles. Hypothetical particles that rarely collide with ordinary matter. They could pass through your body, through planets, through entire galaxies without leaving a trace. Others propose axions, tiny ghost-like particles that could drift through the universe in vast clouds. There are even ideas involving sterile neutrinos, primordial black holes, or entirely new forms of quantum fields, exotic ingredients that lie beyond our known physics. Deep underground, in mountains and mines around the world, scientists have built immense detectors, quiet chambers filled with supercooled liquids, waiting for a single dark matter particle to strike. So far, nothing. Yet the search continues because the mystery is too vast to ignore. The dark symbiosis. Dark matter does not act alone. It dances with dark energy, the other unseen force that drives the expansion of space. Together, they dominate the universe. Dark energy pushes it apart. Dark matter holds it together. One expands, the other binds. Two invisible forces, opposite in nature, yet perfectly balanced, shaping the story of everything we know. In this cosmic interplay, galaxies are born, stars ignite, and life emerges. Without dark matter, there would be no galaxies for dark energy to separate. The two are partners in a cosmic performance, creation and expansion, structure and silence. the mirror universe. Some theories suggest that dark matter might not be entirely alien. Perhaps it forms its own world, a mirror universe, invisible to us but governed by similar laws. Maybe dark matter has its own particles, its own chemistry, even its own dark atoms. Perhaps somewhere in that shadow realm, structures exist, not of stars and planets, but of something else entirely, undetectable, yet as real as our own. It sounds like science fiction, but so did black holes once. And now we photograph their shadows. The poetry of the unseen. Dark matter humbles us. It reminds us that most of reality lies beyond our senses. We evolved to see sunlight, not the invisible framework beneath it. And yet, through reason and imagination, we've uncovered a truth far greater than our perception alone. A universe built on foundations we cannot see, guided by laws we can only infer. It is both unsettling and beautiful that everything familiar, the Milky Way, the night sky, the atoms of our bodies, is held in place by something utterly alien. We are, quite literally, shaped by the invisible. A universe held together by shadows, so when you gaze at the stars, remember this. Their light travels through a sea of darkness, through fields of matter that neither shine nor reflect. The galaxies themselves drift in invisible halos, tethered by gravity to a structure older and deeper than light itself. Dark matter is the great unseen artist, painting the skeleton of the cosmos, leaving visible matter to trace its contours. We may never touch it, but it touches everything. Without it, the universe would collapse into chaos. A formless storm of particles drifting through an endless void. With it, there is order. With it, there are galaxies. With it, there is us. From the smallest vibration of a quantum field to the vast sweep of galaxies drifting through the cosmic web, the story of existence is a story of expansion. We often imagine cosmic growth as something distant, something that happens out there among the stars. But expansion isn't a phenomenon confined to the edges of the universe. It is written into the very structure of reality, from the invisible ripples of energy that dance through empty space to the grandest scales of clusters and superclusters. In a sense, the universe doesn't just expand, it breathes. And everything within it, including us, moves to that rhythm, the quantum seeds of space. To understand expansion, we must first look where the eye cannot, into the quantum realm. There, beneath atoms and particles, the vacuum is not empty. It seethes with energy, a restless ocean of fluctuations that appear and vanish in an instant. In the first moments after the Big Bang, in a fraction of a second, these quantum ripples were stretched by cosmic inflation. Tiny differences in density, smaller than an atom, were pulled across vast distances, frozen into the fabric of space itself. Billions of years later, those same quantum wrinkles became the seeds of galaxies. Every star, every world, every life form traces its origin to those minute fluctuations, to whispers of randomness amplified by the universe's own expansion. It's a staggering thought. The same physics that governs the behavior of subatomic particles also shapes the arrangement of galaxies across the heavens, the small and the infinite, connected by the same cosmic breath. Galaxies on the move. On the largest scales, the universe behaves like a great expanding ocean. Galaxies are not sailing through it like ships. Instead, the water itself, space-time, is stretching. The galaxies simply drift along with it, carried apart by he tide of expansion. When we say the universe expands, it's not because galaxies are flying away through pre-existing space. It's because the space between them is growing. 1 million light years of emptiness today will be 2 million in the distant future, not because something is moving into it, but because reality itself is stretching. And yet, not everything expands. The Milky Way remains bound by gravity. The solar system stays together. Even the atoms in your body resist this cosmic pull. Gravity, electromagnetism, and the quantum forces of matter all fight back against expansion, holding the universe together at local scales. The cosmic stretching only wins across distances so vast that no force can resist. In this way, expansion and gravity form the two great currents of existence, one pulling apart, the other binding together, and we exist in the balance between them. A universe of layers. The universe is structured like a hierarchy of motion. At the smallest scales, quantum fields pulse and shimmer, a restless foam of uncertainty. At human scales, atoms and molecules bind, creating the tangible matter of life and world. At cosmic scales, galaxies drift apart as the fabric of space itself stretches outward. Each level obeys its own laws, yet none stands alone. The same physics that describes a falling apple also describes the orbit of galaxies. The same equations Einstein wrote for space-time curvature govern the rise and fall of universes. In a way, expansion is not just a process, it's a language, a unifying pattern that echoes across every scale of being. The stillness within motion, and yet, despite this grand motion, from our perspective, everything feels still. We don't feel the universe stretching beneath us, nor the galaxies racing away. We are carried effortlessly, like dust motes in a rising tide, unaware of the flow that bears us onward. Space expands uniformly, everywhere, all at once. That means you, the chair you sit on, the air around you, all are embedded within this growing fabric. But the bonds that hold matter together are strong enough to resist that stretching. You don't expand because atoms are bound by electromagnetic forces. The Earth doesn't expand because gravity holds it. Even galaxies, for now, remain whole, their stars locked together against the universe's push. But look far beyond the galactic clusters, and expansion becomes undeniable. There, space itself stretches faster than light can cross it, dragging galaxies out of sight, erasing them from the visible universe. We are witnessing the quiet acceleration of cosmic isolation, a universe where distance grows faster than connection, bound by forces, freed by space. This contrast between the things that hold and the things that stretch defines our cosmic existence. You are made of atoms born in the hearts of ancient stars. Those atoms obey the laws of quantum physics, bound together by the same electromagnetic force that keeps galaxies intact. And yet the space between galaxies, the vast dark expanse between clusters, yields to another master, the expansion driven by dark energy. It's as if the universe operates on two intertwined principles, one of cohesion and one of release. Gravity builds, dark energy disperses, matter gathers, space expands, and somewhere in the middle, life appears, balanced delicately between creation and dissolution. Expansion within us. But what if expansion isn't just a property of the cosmos? What if it reflects something deeper? A fundamental pattern that echoes through existence itself. From the moment of birth, everything expands. Cells divide, organisms grow, ideas spread, civilizations rise. Consciousness itself unfolds, reaching beyond what it once thought possible. In the same way the universe stretches its boundaries, so too do we. We expand not in space, but in understanding, forever pushing against the horizon of the known. Perhaps cosmic expansion is not only a physical truth, but a metaphor for growth written into the laws of being. A reminder that even as the universe drifts apart, the pursuit of knowledge brings us closer to its heart, the scale of connection. It's easy to feel small beneath the cosmos, a single mind adrift in a boundless void. But scale is an illusion of perspective. The same laws that shape the grandest galaxy also govern the smallest atom. The same mathematics that describes the curvature of space-time also describes the energy locked within you. You are not separate from the universe. You are part of its fabric, woven from the same fields that ripple across the cosmos. You are expansion made conscious, a fragment of reality learning to see itself. The endless continuum. As the universe expands, it stretches not toward emptiness, but toward possibility. Each moment gives rise to new configurations, new forms of matter, new ways for existence to know itself. From quantum waves to galaxies, from particles to people, all are chapters in the same expanding story. A continuum that connects the smallest tremor of energy to the vastest reach of space-time. We are both local and cosmic, bound by gravity yet carried by the flow of creation. Expansion is not something that happens around us, it happens through us. And perhaps that is the quiet truth of it all. To exist is to expand. To be is to unfold, and across space, across time, across every scale of being. What if our universe is not the universe? What if the grand expanse we call everything is only one bubble floating in an endless cosmic sea? For centuries, humans have looked into the night sky believing that what we see, the stars, galaxies, and nebulae, is all there is. But the deeper we look, the more the universe whispers. There may be more, not just more stars or galaxies, but more realities, entire universes, invisible, unreachable, yet perhaps just as real as our own. This is the story of the multiverse, the most astonishing idea in all of cosmology. The tale begins with the Big Bang, or more precisely, with cosmic inflation. In the first trillionth of a second after time began, space itself didn't just expand. It exploded outward at unimaginable speed, doubling in size over and over in a fraction of a heartbeat. Inflation explains why our universe looks smooth, uniform, and vast. But if inflation happened once, could it still be happening somewhere else? According to the theory of eternal inflation, it never truly ended. In this view, inflation is like a boiling pot of water, with bubbles forming here and there. Each bubble becomes a universe. Each expands, cools, and develops its own laws of physics. And we live inside one of them. Our cosmos, the one we know, is just a single bubble in an infinite frothing sea. Inside our bubble, space continues to stretch, stars are born, and life arises. But beyond our horizon, beyond what light can reach, other bubbles expand too, forever isolated, forever unreachable. They may follow different rules. Some may contain no atoms, others no light. Some may collapse moments after birth. Others might flourish with entirely different forms of matter, energy, and even consciousness. If reality is truly infinite, then everything that can happen does happen. Somewhere out there, another Earth which may orbit another sun, identical in every detail. Another, you may be watching this very moment, asking the same question. Infinity doesn't just allow this, it demands it. But can such a vision ever be proven? Can we ever reach beyond our bubble? The boundary of our observable universe, 46 billion light-years away, marks the edge of everything we can see. Beyond that lies the cosmic curtain, where light from other universes could never cross. By definition, the multiverse hides beyond testable reach. And yet, there are clues. Tiny irregularities in the cosmic microwave background, the afterglow of the Big Bang, might reveal scars from collisions with other universes. Patterns in polarization, faint temperature fluctuations, or unexplained cold spots could be hints of where our bubble brushed against another. Some physicists search for answers through string theory, which suggests that multiple dimensions could give rise to countless possible universes, each one a different vibration of the same underlying fabric. Others turn to quantum mechanics, where every choice, every possibility might spawn its own branch of reality. A quantum multiverse, where every outcome exists, each as real as the one we experience. From eternal inflation to quantum branching, from string landscapes to holographic horizons, the multiverse is not one idea, but many. A constellation of theories pointing toward one haunting truth. Reality might be larger, stranger, and more abundant than anything we can imagine. But beyond the equations lies something deeper, something profoundly human. The multiverse challenges our sense of meaning. If infinite versions of us exist, what makes this one matter? If countless universes unfold, does ours hold any special place? Perhaps it does, because within this vast infinity we are the only ones who can know we exist, the only ones who can stand beneath a quiet sky and wonder about it all. Maybe that's the real miracle, not that infinite universes could exist, but that in this one, consciousness arose to ask why. And so we return to the question that started it all. If the universe is expanding, what lies beyond its edge? Maybe the answer isn't nothing. Maybe beyond the horizon lies infinity, a boundless realm where creation never ends, where universes are born from the breath of quantum foam, and where existence itself is eternal. Our universe may be one note in an endless cosmic symphony, but even a single note, when heard, fills the silence with meaning. As we move forward, we descend deeper, beyond the edge of universes, into the heart of nothingness itself, a place where even creation dissolves, where everything becomes one. What if the universe expands into nothing, because it is everything? Every galaxy drifting away, every atom stretching through time, all part of one silent unfolding. And you are within it. Not separate from the expansion, but carried by it. Every heartbeat, every breath, every thought, echoes of the same cosmic rhythm. Since the dawn of awareness, humanity has searched for the meaning behind the stars. We've measured their distances, mapped their movements, and uncovered the laws that govern them. But beneath every discovery lies a deeper truth. The universe is not expanding into space. Space itself is expanding. There is no edge being pushed outward, no emptiness being filled. Reality, as we know it, is creating more of itself. The galaxies aren't traveling through space like ships across an ocean. They are passengers on the ocean itself. As the ocean grows, the fabric of reality, the invisible geometry of space-time, stretches, and with it, everything inside. That means there is no center, no privileged point where the expansion began. Everywhere is expanding away from everywhere else. And in that sense, every point is the center of the universe, even here, even now. To understand this is to see that the universe is not simply out there. It is here, unfolding within you. The same equations that describe galaxies drifting apart also describe the energy vibrating within your body. The same quantum fields that birthed the cosmos give rise to the atoms in your bones. The same expansion that carries light across billions of years also carries the electrical impulses that form your thoughts. You are not in the universe. You are the universe, aware of itself. In you, the cosmos found a way to look back and ask, why? From a scientific perspective, cosmic expansion is governed by one mysterious term: dark energy, the unseen force that drives the universe apart faster and faster. It makes up nearly 70% of all that exists, yet its nature remains unknown. We can measure its effects, we can model its consequences, but we cannot yet say what it is. Perhaps dark energy is not a thing, but a property of space itself. The breath of existence woven into the very geometry of reality. When space grows, it does not grow into something. It grows because growth is its nature. Because creation is not an event. It is a state of being. Imagine the universe as a painting still being painted. Each brushstroke adds more canvas, more color, more meaning. But there is no frame, no border to contain it. Only an infinite process of creation, unfolding from within. This process doesn't just describe galaxies. It describes you. Your cells expand, divide, and renew. Your mind evolves, exploring ideas and emotions that never existed before. Every moment, your consciousness expands, just as space does. The same universal law that stretches galaxies also stretches your understanding. In every sense, you and the universe share the same fate. Perhaps that's the ultimate meaning of expansion, not a cosmic accident, but a reflection of awareness itself. Maybe consciousness and the cosmos are not separate phenomena, but two aspects of the same unfolding reality. The outer universe expands in space, the inner universe expands in thought. When we look up at the night sky, we are not observers peering into a distant void. We are fragments of that very sky, questioning itself. When we ask, what lies beyond the universe, we are really asking, what lies beyond us? And the answer may be the same. Nothing. Not emptiness, but boundlessness, filled with no outside, because it includes everything that is. There is a quiet beauty in this realization that we, made of dust and light, are part of something that has no edge, no end, no destination. The universe does not need a reason to expand, it simply is. And in being, it allows meaning to arise from within. Our stories, our lives, our civilizations, they are all patterns of energy shaped by the same laws that sculpt galaxies. When we love, when we create, when we dream, we are continuing the universe's expansion in a new form, not of matter, but of mind. Perhaps that is what cosmic purpose truly means. Not a goal imposed from above, but a continuation from within. The expansion of being, from atoms to stars, from life to thought, from matter to meaning. As the universe stretches outward, it also deepens inward. In every moment of curiosity, every act of creation, we extend its reach, not in distance but in understanding. In asking why, we become part of its unfolding story. So maybe the universe doesn't expand into nothing. Maybe it expands into itself. Because everything and every particle, every mind, every heartbeat is already within it. And when you breathe, you participate in that same expansion. Your lungs mirror the cosmos, inhaling existence, exhaling awareness. You are not apart from the cosmic dance. You are the dance. In the end, perhaps this is the meaning of expansion. To grow is to be alive. To expand is to exist. And the universe, in all its mystery, is both. It is not a cold machine or a meaningless void. It is a living process, one that questions, learns, and creates through us. Because when we look up and wonder where the universe is going, we are in that very moment fulfilling its purpose. The universe expands, and so do we.